Hello viewers, in today's class we are going to discuss yet another important and very conceptual problem from integration, right? So here we have this problem to solve, and we have to solve this integral from 0 to 1, and here we have the radical sign, that is 1 by 4th power of 1 minus cube root of x, right? So here we'll solve this integral using the concept of beta gamma function, right? So let us call this integral as I, and first we'll make use of the method of substitution. So now here let us substitute t is equal to cube root of x, right? So we can write t is equal to x raised to 1 over 3. So here I will make this substitution, that is t is equal to cube root of x, so that we have t cube is equal to x, right? So let us differentiate both sides with respect to x. So we have d by dx of t cube, and here we have d by dx of x, right? So here we have 3t square and dt over dx, and here the derivative of x with respect to x is 1. So now we have 3t square dt is equal to dx, right? So for this dx we have 3t square dt. So now here we see that the limits of integration vary from 0 to 1. So when x is equal to 0, then the value of t is also 0, right? 0 raised to 1 over 3, that is 0, right? And when x is equal to 1, then the value of t is also equal to 1, that is 1 raised to 1 over 3, that is 1, right? So now we can rewrite this integral I as I is equal to 0 to 1. We have 1 minus x raised to 1 over 3 raised to 1 over 4 dx, right? So we can also rewrite this integral like this. So we can now convert this integral in terms of the variable t. So we have 0 to 1, 1 minus x raised to 1 over 3 is t. So we have 1 minus t raised to 1 over 4, and for dx we have 3t square dt, right? So viewers, we can now write it as 0 to 1, and here we can take 3 outside the integral. We have t square, here we have 1 minus t raised to 1 over 4 dt, right? So now we can convert this integral into beta integral, that is 3. Here we have 0 to 1. We can express t square as t cube minus 1, and 1 minus t raised to 1 over 4. So we can write it as 5 by 4 minus 1, right? And here we have dt. So we have converted this integral into beta integral because we know that beta mn is given by 0 to 1 x raised to m minus 1 and 1 minus x raised to n minus 1 dx, right? So now if we compare this integral with this one, then the value of m is 3, because here we have t raised to 3 minus 1, here we have x raised to m minus 1, so m is 3, and here we have 5 by 4 minus 1, because 5 by 4 minus 1 is 1 over 4. So the value of n is equal to 5 by 4, right? So now here we should remember that m and n should be greater than 0, right? And this beta integral is also known as Euler's integral of first kind, right? So now this integral I becomes 3 times beta of mn, right? So this integral is now beta mn, and we have beta mn, m is 3 and n is 5 by 4, right? So now to evaluate beta 3 comma 5 by 4, we can make use of one important result which connects beta and gamma function, right? So beta mn is equal to gamma of m, gamma of n, and here we have gamma of m plus n, right? So here we have 3 and 5 by 4. So beta 3 comma 5 by 4 is equal to gamma of 3, gamma of 5 by 4. Then here we have gamma of 3 plus 5 by 4, right? So now we know that gamma of 3 is equal to 2 factorial, because we know that gamma n plus 1 is equal to n factorial, right? So here we have gamma 3 is equal to 2 factorial, which is simply equal to 2. So we have here 2 times gamma of 5 by 4, and here we have 4 3s are 12, 12 plus 5, 17 over 4, right? So now we can write this integral I as 3 times. Here we have beta 3 comma 5 by 4, which is equal to 2 times gamma of 5 by 4, and here we have gamma of 17 by 4, right? So this is 6 times gamma of 5 by 4, and here we have gamma of 17 over 4, right? So now we'll simplify this expression, right, using another important result from gamma function. Now viewers, we know that gamma of n plus 1 is equal to n times gamma of n, right? So here we have gamma of 17 over 4, which can be written as gamma of 1 plus, or we can write it like this, 13 over 4 plus 1, right? So here we have gamma of 13 over 4 plus 1, which can be written as 13 over 4 gamma 13 over 4, right? So due to this result, because see, n plus 1, so here we have 13 over 4 plus 1, so the value of n is 13 over 4, and here we have n times gamma of n. So we can apply this result successively to this term. Then we have 13 over 4. Here we have gamma of 9 by 4 plus 1. So this is 13 by 4. Then again applying this result to this one, we have 9 by 4 and gamma of 9 by 4, right? So we can now write 13 by 4, 9 by 4, and again applying the same result to this one, we have 5 by 4 plus 1. So this is 13 over 4 times 9 by 4 times 5 by 4 times gamma of 5 by 4, right? So viewers, the value of gamma of 17 over 4 is given by this expression. So substituting the value of gamma of 17 over 4 over here, the value of I is 6 times gamma of 5 by 4, and here we have 13 over 4 times 9 by 4 times 5 by 4 times gamma of 5 by 4, right? So here gamma of 5 by 4 and gamma of 5 by 4 get cancelled. So we are left with 6 times. 4 times 4 times 4 is 64. And we have 13 times 9 times 5, right? So taking 64 to the numerator, right? So here we have some common factors, so we can cancel them out. Here we have 3 2s are 6, here we have 3 3s are 9, right? So we have 2 times 64 is 128, and here we have 13 3s are 39 times 5, so this is 128 divided by 5 9s are 45. 5 threes are 15. 15 plus 4, 19, right? So we have 128 over 195, right? So viewers, the value of this integral is equal to 128 divided by 195, right? So this is how by making use of the concept of gamma function and beta integral, we can solve these kind of integrals.